words. And this is a theme with math people. So today is 12/8. I like to date my notes so that I can get them in order if I have several sets of them. And what we want to start with Roman numeral 1 today is kind of a recap, but it's super worth doing. So what we're going to recap is actually Unit 1 from this year. Take a second, jot that down. And Unit 1, I don't know if you remember, was all about proportional relationships. So Unit 1, proportional relationships. And you guys actually talked about this for you talked about it last year too. So the deal with math folks is they are obsessed with looking at every math topic 4 different ways. Okay. And they're going to harass you with this from now all the way through your math classes. And so we're going to just kind of make an organized box of knowledge related to proportional relationships in these 4 methods. So kind of big on your page. Get yourself a big old box. There we go. We want 4 quadrants, 4 pieces, because there are 4 different ways that we math teachers obsess about math problems. And they'll start looking familiar once we organize them. So the first way that we like to think about math problems, particularly proportional relationships, is through words. So these are like the story problems that we throw at you all the time. I'm going to give you an example in a second. So our example for proportional relationships, we're going to be talking about Audra. And Audra's neighbor. Audra's neighbor has asked her to feed her cat while she's out of town. Okay, so Audra's neighbor needs her cat fed while the neighbor's traveling. Audra has gladly agreed because she wants to save up some money. And they tell her they will pay her $2 each time she feeds the cat. So Audra's neighbor needs her cat fed, and they are going to pay her $2 every time she feeds that cat. This is an example of a math problem via words. Okay, so take a second, jot that down. And then we're going to label our other boxes. So box 2 over here is tables. We're big into tables. That's another way that we like to look at math problems. Another box is graphs. Also super popular with the math teachers. And finally, equations. Words, tables, graphs, and equations. Those are our 4 ways we will always be looking at math problems. Now, what I want us to do with Audra and her cat feeding situation is I want us, under our table chart, is to create a table to model Audra's situation. Okay, we're going to make a table. In this column, I'm going to put number of meals. In the other column, I'm going to put the money. I'll make a few lines. We're going to have number of meals. And we're going to have money. And then we'll just start at 0 and count up a few. So 0, 1, 2, 3, 4. And then I want you guys to fill in the money side based on our word problem. And then we'll check it in just a second. I'm not able to add you as a co-host, so I think that's fine. Okay, let's go fill these guys in. So for no meals, she makes no bucks. We got a 2, a 4, a 6, and an 8. Does that match you guys? 0, 2, 4, 6, 8. Okay, perfect. Okay. Things to remember about tables and proportional relationships is that we often, do I want to do that here? Yes. We often ask you guys, nope, I'm going to come back to that part in a second. We often look for patterns, but we'll get there in a second. Now, after we've made this table, do you have a prediction about what's coming next? Oh, here it goes. Create a graph. Based on your table. Be sure to label it. Now we're going to create a graph based on our table. Some dots on this graph. Once you get your graph, take a peek at mine. Make sure you've got dots, lines, labels. I'm even going to label some of my dots. Take another minute or two to get that graph done. Okay, and then below our big quadrant with the squares, we're going to start listing out some characteristics of proportional relationships. Because as we talk about your graph, we want to write down these interesting and important characteristics. That's our goal. So we have characteristics of proportional relationships. Okay, team, our first characteristic of proportional relationships is hanging out right here at the point 0, 0. Every proportional relationship goes through the point 0, 0. So we're going to say it passes through point 0, 0. We math people sometimes call this the origin. Y'all use that language? 0, 0, you call it the origin? Okay, super. I didn't want to use a word that's unfriendly. Perfect. So our proportional relationships always pass through the origin every time. Proportional relationships are also always going to be a line, which we have. So these, sometimes we even call these a linear relationship. They're going to look like a line when we graph them. That's why we like graphs. Sometimes we can see the line. Okay. Next, last on our list, we have something super important, and she is called, that disappeared, come back, the constant of proportionality. Number 3, we have that constant of proportionality. And of course, it has another name because math people they always have multiple names for the same thing. See in your mind, see if you can remember another name for the constant of proportionality. Starts with a U. Unit rate. Cool beats, guys. There she is. So I might also ask you about the unit rate. And pretty frequently we use the letter K for the constant of proportionality or the unit rate. And we make her by forming a fraction. So the constant of proportionality is always a fraction. She might be simplified, but we start out with a fraction. And we always put the y coordinate and divide her by the x coordinate. Okay, that's how we make the constant of proportionality. So we're going to look at that in our table, and we're going to also look at it in our graph. And I think we'll start with the graph. So my x-axis, that's always the horizontal one. I've labeled her x over here, kind of messily. And the y-axis is up and down, the vertical one. So if I were to label a point under here, the x coordinate always comes before the y. So sometimes it's helpful to write x and y below them. But I'm super grateful because at least the math people put them in alphabetical order for us. So the x is first, the y is second. And every one of these is an XY pair. Now, what I'd like for you to do, please, is I'd like for you to find the constant of proportionality using any of these points on your graph. So you'll make a little fraction out of it, simplify. I think I'll pick 3 and 6. Thumbs up if we get to a match in the end. That helps me know that I haven't gone off the rails. Okay, did people get 2? Did we get 2? Awesome. Okay, did anybody use the same point as me, 3 and 6? Any folks? Okay, what about 1 and 2? Anybody use 1 and 2? Yep, okay, a couple folks. 2 and 4? Who used 2 and 4? Hey, good choice. 4 and 8? Okay, the only one that fails is the origin. We can't use her because it gets crazy town. I don't know if you've ever tried typing in 0 divided by 0 on your calculator. She probably gives you an error message and gets super grumpy. Now let's put some units on this constant of proportionality. because we have a story to go with it. So this constant of proportionality represents $2, because that's my y coordinate. And then we use the word per for rate of change. And then the x-axis is meals. So $2 per meal, or a meal. Okay. I want to go up to our table, and I want to also show a little work finding the constant of proportionality. So this time I'll use like 8 and 4. So up at my table, I'm going to show the work. And the reason is because you can see the constant of proportionality because she shows us our multiplying pattern between x and y. So I take 3 times 2 and I get 6, 2 times 4. 1 times 2, I get 2. So if we're looking at a table, that's a way we can see. It's the multiplying pattern. Okay. Now, last on our list, we got to deal with equations, and proportional relationships have an equation that usually looks something like this. We got y equals k times x. And k, she's our trusty constant of proportionality, or our unit rate. And you may have predicted, I'd like for you to take a second and write an equation to model Audra's cat job. So take a second, write an equation to model it. I'm going to write mine, you write yours and check it. Remember, we leave the y as a y. Leave the x as an x, and we just plop in that constant. We put a 2 down. So y equals 2x is exactly the answer that they're looking for there. Okay. I want to go back and highlight or underline a couple of things. So if you have colors, this is a good time for colors. So in green, we highlighted the origin on the graph. And I'm going to put her highlighter on my table because there she is, hanging out. That's my initial value. And then in yellow, I'm going to highlight constant of proportionality. And we see her with our multiplying pattern in our table. We see her right here as the 2 hanging out. And in my word problem, there she is when they pay her $2 each time she feeds the cat. So she pops up in several different ways. Now, this is the scoop and skinny on proportional relationships, and math people are notorious for saying, oh, that's super cool, but what if we change it up a little bit? And so that's what this current unit you're going to talk about tomorrow is. So now we'll flip to the next page, out of recap zone, and I believe in you. There we go. And we're going to do Roman numeral 2. This is unit 5. So your current unit. And this unit is called linear relations or relationships. And sometimes we use the word functions. Unit 5 is about linear relationships or linear functions. So take a second and jot that down. And we want to put a little note under this. So Unit 5, linear relationships. And this note goes something like this. A proportion is one type of linear function. So a proportion is one type of linear function. This graph with a line. But now we want to also look at other types of linear functions. That's our game here. And it's going to start out the same way as our last bit. We're going to look at it 4 ways. So we're going to draw our big old chart. Divide it into 4 boxes, 4 quadrants. And I bet you can guess what we're going to label up. We got words. We got tables. Graphs. We got equations. Words, tables, graphs, equations, and below our giant box of fun, we're going to list out the characteristics. Linear relationships. Take another second and get all this stuff labeled, and then we'll start filling in. Okay. We are going to loop back to Audra. Audra has gotten another pet sitting job, this time for guinea pig. New family, different neighbor. And is pet sitting for guinea pig. Do any of you guys have a guinea pig? Any guinea pig owners in the crew? No, we don't have a guinea pig in my house. Just a little different setup with the family. So they have a little different payment structure here. The family has said, we will just pay you $7 to start out with. So just boop for signing up. And then they're going to pay Audra $3 each day she checks on their pet guinea pig. Okay, so they're going to start out and just pay her initially $7. So initially they pay her $7 plus $3 each day. Oopsies, that she checks on her pet. So she's pet sitting for a guinea pig. They pay her $7 plus $3 a day. And we're going to loop back to this word problem after we've done some of our other things, and we'll highlight important phrases in here. But just like we did before, let's get started and make a table. Model Audra's job. I'm going to label the left column her number of days. And the right column is many. And then just like last time, we'll start at like 0 days and then do maybe 1 and 2 and 3. And I want you to fill in her money. So how much does she make? Did you get it rolling? Check in with me. Make sure that we match. Okay, take a second. And then peek and compare when you're ready. Okay, do we have matchy match? 7, 10, 13, 16. Feeling good about it? Okay, perfect. We're gonna fill in this white space I have over here to the right in a minute, but not yet, because we're gonna go on over to our graph. So create a graph. Just like before, we want to label it, put our points on there. I'm going to count by twos. Take another moment or so, get your graph done. Make sure you have your labels. I put mine in red. It brings math people much joy. And in your mind, I want you to be comparing and contrasting. How is this similar to our proportional graph we did? How is it different? Be thinking about that because that's going to be important. It's a very mathy thing to do. Okay, let's talk about some of these things. First on the list, I'm going to put this under our characteristics. I notice my graph does not go through the origin. She goes through this other green point. And for these problems, we call that green point the initial value. So we're going to write that down. It has an initial value. An initial value if I wrote out its XY pair, its point in the table, it would always be 0, comma, some number. Every time. It always has an X coordinate of 0. And then it's a number. On your paper, I want you to write the initial value for Audra. Two ways to write it. I'll show you. We can either say that her initial value is just straight up 7 and just list the Y coordinate if we're feeling lazy. Or sometimes we list it as the full XY pair, 0, comma 7. This is something, y'all, you'll want to pay attention to how your teacher has you do it, because every teacher is a little bit different on how they prefer for you to write the initial value. So we wrote down the two most common ways. And I'm going to take my green highlighter, and I also want to find this initial value in my table. Wait for it. There she is. Boop. And in my word problem, it's what they paid her to begin with. So her sort of starting fee. So there sits our initial values. Turns out, just like proportional relationships, a second characteristic of linear relationships is that they're lines. So that's a similarity between the two. Then our third one is related but smidge different. Come on, you can do it. And the third characteristic is eluding me. Hold tight, guys. My pen disconnected, so I have to go do a reconnect. Give me just a second. Okay. So then the deal with the third characteristic, this is kind of like our unit rate or our constant of proportionality, but for linear functions, they call it a rate of change. Worth highlighting in yellow because it's super important. So the rate of change also has a letter, but she is not, write it over here. She is not K like constant of proportionality, she's M, but we do make her by making a fraction. And just like before, we're going to put the Y's on top and the X's on the bottom. And so we're going to say that the rate of change comes from the change in the Y coordinates. And I'll show you what that means over the change in the X coordinates. So the change in the Y coordinates over the change in the X coordinates. Sometimes math people use a super official formula. They call it Y2 minus Y1 over X2 minus X1. And you guys may have come across this before. I'll show you on the graph to see if it's familiar. But this is a formula worth knowing by heart. Boop, boop, boop. So I'm putting her in a little cloud here. And I think we'll start with our graph. So if we want to see our rate of change in our graph, then one thing math teachers sometimes have you guys do is draw like a triangle under the graph. Like I might do this one and connect two dots, one going across and one going up. Have you guys ever done these wedges or these triangles before? Okay, I feel like they would have been in your past. Okie dokie. And the deal with the rate of change is that we're going to figure out how far apart are the X coordinates. So I noticed this one's at 1, and this one has an X coordinate of 3. So to find their distance, I'm going to subtract them. So 3 minus 1 is 2. That's my change in X. We want to do something similar with the y coordinates. This one has a height of 16. This other one has a height of 10. And I want to know how far apart are they? How much did my y change? And I can just subtract. So I got my 16 minus my 10 is 6, and she's my change in y. And then if I want to know my rate of change, I just make a fraction out of those. I'll put the 6 on top. I'll put the 2 on the bottom and simplify. I'm going to highlight this business in yellow because it all kind of goes together. So there's my rate of change for Audra's situation. See if you can find the rate of change in either the words or the tables. We're going to highlight those. There she is right there in the words. That was nice and easy. In my table, she's a little bit more hidden. You can kind of see a +3 pattern happening here. But that's because these guys are a +1 pattern. But if I take this change in y divided by this change in x, I get my rate of change divided by 1. Now we're rolling up to our equation. And the equation is going to start out looking a whole lot like our, don't write this part down yet. I'll show you. So there's our constant, our proportional relationship equation. You don't have to write this part down yet. Now here's what happens. We said that linear relationships, we don't use the phrase constant of proportionality. So they erase the K. And in her place, they put M. And that part you can write down. I won't erase anymore. So our equation starts out with y equals mx. But then we have to factor in that initial value. And what happens is she's added on. Plus, they use the letter B. They're kind of weirdos in that way. But that B represents our initial value. So we got y equals mx plus b. There's our formula. Your job is to lickety-split write an equation representing Audra's guinea pig sitting job. So your job is to now fill in the pieces and write an equation. When you're ready, you can peek up here if you need a hint. Okay, team, in the end, we knew our rate of change. She was 3. Plopped her in for M. We knew our initial value was 7. The x stayed x, the y stayed y, and we just won the equation game. Okay. Now what I want to do is start showing you guys different ways that we math teachers ask you to deal with all these different things. Okay, so these are kind of examples of problems that we might throw your way. I'm choosing this one first. Okay, so here's our next example. This is like Roman numeral 3 examples. We're going to start with example 3. Example 3 goes like this. We've got a line described by, and for this problem, I'm going to hand you the equation. Y equals 1/2 x plus 3. So line is described by 1/2 x plus 3. I'm going to hand you the equation. And for part A, I'm going to ask you to create a table. So create a table to show several solutions. Those are just XY pairs that work. Let's get busy. So you have freedom to choose your X and Y values. I'm going to be lazy, embrace my inner lazy mathematician. And I'm definitely putting 0 in because she's a nice and easy number. And then I'm also boring, so I'm going to do 1, 2, 3. But you could have done other numbers, 10, 50, -5, your choice. And then to find your Y value, we're substituting. So the Y is apparently 1/2 times X plus 3. Oops. Oops. Okay. I want us to now graph this thing. So use your table. Let's sketch a graph. And once you get your graph done, I want you to grab a color pencil or get ready to label stuff. And for part C, I want you to highlight or underline or label the initial value in the equation, table, and the graph. So I want you to be able to find it on all three. So label it or highlight it, your choice. Green. Okay, next on my list, I want us to practice using our rate of change formula. We're going to use our rate of change formula, and I'm going to ask you to use the points 3, 4.5 there on my table. And 1, 3.5 to determine rate of change. Maybe peek back on the other page, jot down that rate of change formula. It's like with the Y2s and stuff. So jot that down and then we'll apply it together. Now, sometimes my students look at me and they say, hey, Ms. Bull, how do I know? How do I know which point is like X1, Y1 and which one's X2, Y2? It turns out it doesn't matter. Okay, so you can pick. I usually just go in the order that they appear. So I'm going to call my 3.5, 3, 4.5 is my X1 and Y1, my first point on the list. And then the other one's X2 and Y2. If you flip-flopped them, that's fine. You'll get the same answer. They'll just simplify to the same thing. Oops. And I'm going to plug in my points. So 5, 5. Subtracting my y's. Subtract my x's. -1 on the top and like -2 on the bottom. Which is technically, it's okay, but it kind of creeps math people out to have a negative number divided by another negative number. They're going to say, oh, negative divided by negative. That'll give me just regular positive 1/2. And at this point, I'm smiling because that is indeed my rate of change number that I expected to get based on my equation. I want to sneak in one more problem for us. This time, instead of me giving you the equation, this time I'm going to hand you a table. So here comes example 4. I'm going to say this table represents a linear function I don't have any context. I'm just giving you X and Y's. So this table represents a linear function and inside there I got 0 and 15. I got 2 and 27. And I got 4 and 39. So there are 3 solutions, 3 points that would be on the graph of this line. And for part A, I want you to identify the initial value. Take a peek at this table. See if you can find the initial value, write it down. And I want you to write it down in the 2 different ways that your teacher might have you write it down. So we talked about 2 different ways. You may have to peek back in your notes to see the 2 different ways that we write down initial values. There she is sitting at the tippy top of my table. You might say the initial value is 15. Or your teacher might want you to write out the whole point. There she is, 0, 15. Okay, next part. Let's find the rate of change. What is the rate of change? And you can choose to use a graph. So you can make the graph and draw the wee triangle. You can use the handy dandy fraction formula, your choice. You get to pick whichever points you want. And the points you pick might not be the ones your neighbor picks. So choose your own adventure. I'm lazy. I think I'm going to use these 2 points. Oops, nope, nope. It's not my formula. Six. Did y'all get 6? Maybe I got a couple of nods. Yep, a couple of thumbs up. Thanks, y'all. 6 she is. There's her rate of change. Oh, the timing is so perfect. It's 8 o'clock, but I only had one last question to ask you guys. You might can predict it. Write the equation of this linear function. Got a y equals 6x plus 15. Perfect. Perfect. Okay. I'll let you go in just a second. Looking forward, there are more combos, more ways that we can ask you guys to sort of wrestle with this stuff. So next Sunday, I'll try to keep a pulse on what y'all are doing in class, and I'll make sure that we're doing example problems that kind of match those and preview the next week. That's our goal. Pop in on Thursday for tutorial if you want to do an activity around this stuff. And I hope you guys all have a great week. Thank you guys so much. It's good to see you all. Bye.
Bye.
Later, Gators.